So acceleration is the next thing that we're going to be going on to, which is the change in velocity. So the rate of change of velocity over time. Now, it's meant to say over time, not with over time. So just the rate of change of velocity over time. Mathematically, it's dv by dt, or the change of velocity over time, so delta v by delta t. We also know that v is ds by dt. So if we just rewrite this, dv by dt, this is the same as d by dt of velocity, which is ds by dt. And multiplying this out, you get d by dt, so d squared s over dt squared. But it's mostly said d2s by dt squared, because d squared s can be a bit of a mouthful to say, so we just say d2s by dt squared. So that's where this expression comes in. It's the second derivative of position with respect to time. This last little bullet point, if you're familiar with the chain rule, you should be able to find this, but if you're not, then it doesn't matter too much. We can note that using the chain rule, we can introduce a ds on top and bottom, because these would just cancel anyway. So that's just introducing via a chain rule. So v is ds by dt here, so a is also the change in displacement over time multiplied by the change in velocity over displacement. So there's now a lot of different ways of running it. So dv dt, d2s by dt squared, and v dv ds. So there are a lot of ways of writing acceleration. You just got to be careful with knowing them. These three in particular are the more common ones. This fourth one, not so much, but it's still handy enough to know.